Oh, wait. Oh, okay. That's right. Then it's Raymond. Then Raymond is discussing your case. Raymond, yeah. He's online. Yeah, but he's here. All right. Let's get started. The floor is yours.
It's green.
Green.
Yeah. Okay. All right. Thank you. All right. So back to urban water. So we are going out of the irrigation and now going back to urban water. And this is a project with working with University of Tunis. This is my PhD student, and this is a colleague from the University of Tunis. So fundamentally, the issue is related to climate change and related to investments in water utility. So water, domestic water or urban water in Tunisia is provided by a public water utility. And we have problems related to issues of quantity and quality of water. So this is not a problem related to Tunisia only, but it's a global problem. And challenges of maintaining water quality in urban areas led fundamentally to escalating global demand for bottled water due to health concerns and preference for water quality. The global water market in 2022 was around $300 billion. And it is expected to grow annually at 6% from 2023 to 2030. 1 million bottles of water are sold every minute around the world, every single minute. We are talking about 1.5 billion bottles of water. So is this the best option? Is it what we want from an environmental point of view, from a welfare point of view? Definitely it is not. And then if it is not, so how we should be going around it? So there are several factors shaping the demand for bottled water. And these factors are not the same in developed countries and in developing countries. My presentation today is going to be fundamentally related to Tunisia, which is a developing country. And then what we are doing is looking to bottled water as a substitute for drinking water, for tap water. So we have done a survey about in-home bottled water consumption. It's not general bottled water consumption, but precisely in-home bottled water consumption. And we are looking forward understanding the reasons for that. So in Tunisia, again, if you look to the consumption of water, it went from 900 million to 3.3 billion in 10 years, approximately. So besides to the environmental problems, which I've already mentioned, plastic, induced traffic congestion due to transportation of this bottled water, CO2 emissions, most importantly, the bottled water affects and impacts the household finance. So then the bottled water negatively affects the public water utility because people are looking for individual solutions and they are not looking for collective solutions by the public water utility. So maintaining lower than cost domestic water prices is one of the major problems causing degradation of the quality of water delivered at home. This, I mean, the lower cost than the price is bringing to the lack of maintenance of the infrastructure and no upgrading of the treatment process. And then the other issue is that we are not taking into the price the opportunity cost of water. The raw water is not taken into consideration. So what are the consequences of not taking the opportunity cost of water into the price? Fundamentally, the water system in Tunisia is based on several reservoirs, several surface reservoirs, interconnected. And then up to last year, the sedimentation of these surface reservoirs is 28%. So 28% of the capacity of these reservoirs is gone. And then because consumers are not paying for the opportunity cost of water. There is no dredging, no sediment removal in these reservoirs. And then the opportunity of building new reservoirs is almost impossible in the country. All right. So this is the ratio of cost coverage. You can see it went from 1995 to 2015. The water utility in Tunisia was an example, a good example in African countries. It was really, I mean, the World Bank specialists were using the water utility in Tunisia as a good example how cost recovery was good. But unfortunately, this went down, and then we are now recovering less than 70% of the cost. So this started going down since the beginning of year 2000. All right. So the price is less than 70% of the accounting cost, and 70% of the household pay less than 30 Tunisian dinars per quarter, including wastewater treatment and value-added tax. This is equivalent to 0.085 Tunisian dinars per capita per day. You know what is this? It's less than the price of one single cigarette. One single cigarette. Okay. So now the argument is that I have been invited to give a talk to the Cabinet of Minister of Water, the Agriculture in Tunisia in 2017. And then I raised this issue of price, and they said, no, well, it's not possible to increase the price, and we have tried to increase the price, and we proposed this to the Cabinet of Prime Minister, and Prime Minister rejected it because there are elections. So there is a complication. The water utility does not have the freedom to change prices. So you have to go water utility, Minister of Agriculture and Water, and then Prime Minister. And it is really complicated. While all other prices are changing every single day, the water price has to be there. And you have to justify, and you have to do a lot of work, administrative work, to change it. So consumers consume around 50 cubic meters per quarter, which is equivalent to 100 liters per capita per day, which is quite reasonable. The first impact that can be seen is on the leakages, which represent 24% of the total leakages in 2021, and less than 1% of the network is maintained annually instead of 10%. So that is really quite impressive, and which is leading to corrosion of the network and deterioration of the water quality provided to people. Now, what would happen if we improve, we recover cost? What is going to happen? Essentially, it's going to be a sort of 80% increase of water. But again, 80% of increase of water is the price of 2 cigarettes per day instead of 1 cigarette per day. It's not really that important. So, and then the last 2 years, drought that affected the raw water quality is really fundamental, and we have to think about long-term solutions for that. So what we have done here is fundamentally an econometric analysis. We interviewed 880 households on door-to-door interviews in 43 districts in Tunis capital. We worked with the National Center of Statistics for the sampling design. And of course, we got a response of 95% responded to this survey. And then, as I mentioned, our studies concentrated exclusively on in-home demand for bottled water, and considered the existence of home water purification system in the interview. So we asked if you have a water purification system or not. And then as a methodology, we looked into the TOBIT model, which handles sensory data. In our study, 20% of the households do not consume any bottled water in home, and this leads to sensory data. And then we used the double hurdle model, which is appropriate for data where the decision to purchase and the quantity consumed are separate processes. So first decision is to participate in the market, and the second decision is to decide how much bottled water is going to be bought. So this accounts for the zero consumption. And in fact, the zero demands reflect the household's decision not to participate in the bottled water market. So here is the public model. So here is the latent endogenous variable representing the level of demand. And then Y I is the actual level of demand. And beta is the corresponding vector parameters estimated, which represent the household characteristics. So this is the public model, and this is the double hurdle model. Again, here we have equations 4 and 5, where yi is the participation decision and y2 is the demand decision, as I mentioned, because there are 2 steps in the demand. All right. This is the likelihood method, which is we are using the log likelihood function of the double obstacle model, compared to the public model. And here we estimated the probability of participation and the conditional level and the unconditional level of demand for the bottled water. Now, we did the specification tests and we computed the chi-square. And then the decision is that we reject the public model. It's not appropriate because we have a problem of hemoscedasticity problem. And then we concentrate on the double hurdle model. All right, the double hurdle model results are shown here. And fundamentally, I would like you to concentrate on what is the most important result here. The demand is fundamentally explained by the quality of the water. People are buying bottled water. Fundamentally, the major explanation of it is the quality of the water tap. Okay. Now, those families who have purifiers at home, they are not buying bottled water. And there are other variables that affect the demand. Among these variables, the most important ones are having a baby at home, having a child, or having all parents. These also are variables apart from the quality of the tap water. So the major results here shows that factors such as unpleasant taste, odor, lime scale, and safety issues play a significant role in consumers' preference for bottled water. The deterioration of tap water quality significantly increases the probability and quantity of bottled water consumption. 50% increase in probability and a 50% increase in quantity resulted as quality of the water goes down. And the probability of buying bottled water decreases by 15% when households have in-home water filtration systems in place. The model has also shown that more educated and wealthier households are more likely to consume bottled water. This is contradictory with some literature review. In developed countries, we would find that more educated people tend to buy less bottled water because of the environmental issue. And having a baby, child, or elderly parents in the household also increases, increases the likelihood of using bottled water. And the probability of buying bottled water decreases by 15% when households have an in-home water filtration in place. The Hickman's model results are quite similar to the double hurdle model. The quality is 50% again. And then the main other variables are having baby, child, or parents. So in conclusion, our study establishes a negative correlation between tap water quality and consumer preferences for bottled water. The demographic impacts from bottled water are fundamentally related to having babies, children, or older parents. Sorry. And then education and income influence consumption choices. The higher level of education and income are positively associated with greater bottled water consumption. And tap water purifying systems negatively impact demand of bottled water. But again, tap water purifying systems require a lot of investment at the beginning, and it's not affordable by all people. And we are also having the issue of problems owning their own houses and people living in rented houses. They cannot go and install purifying systems, even if they are on the long term much cheaper than buying bottled water. So the implications for tap water quality are quite important here. The findings underscore the significance of implementing measures to improve tap water quality and restore consumer confidence in the water utility services. And this is the major message we would like to convey to the public utility. Don't be worried by increasing water prices. Do whatever you need in terms of increasing water prices. The most important, what people are looking for is getting good water quality. And as I had shown yesterday, the low-income consumers are most hurt by buying bottled water. Instead of spending 2%, 2.5% of the income for water, now they are spending like 7% of the income for bottled and tap water. So the harm is already there, and with improving the tap water quality, we are going to reduce costs for everyone, reduce the welfare impacts, reduce the impact on the low-income households, and improve the water quality for each and everyone. And above all that, reducing the plastic use and reducing the environmental impacts related to the bottled water. Thank you for listening.
Thank you, Slim.
I'd just like a quick comment. Your last point about tap water, is that specific to Tunisia?
Well, we have worked with the Tunisian case, but I guess this applies to several other places in the developing countries. Yeah.
Thanks, Slim. The discussion is going to take place online. Raymond?
Hello, GB. Good morning.
Morning. Over to you.
Thank you very much, GB, and thank you very much, Slim, for that presentation. So I must say, I really like the paper and I enjoyed reading it because one, it's very clearly written and one could easily follow the arguments. And of course, the presentation has even made it better. But having said that, Slim, I have a few comments or suggestions for the paper and to improve the paper. One is the fact that in the methodology section, I think you dwell too much on the mechanics of the econometrics, so one gets no idea how you measure the variables. And for me, there are a few important variables that I would have loved to see in your empirical model. One is, for example, whether the households you are dealing with have access to water, that is, if they have water or taps in their premises, or how far the nearest available water source is from the household. I do not get any sense how you also measured most of the variables in the methodology at all. So one only gets to read the econometrics of the models you are using, and I think there was too much emphasis on it, even to the extent that sometimes you were explaining models that you will not eventually use. So probably you can cut down on this and try to make your readers get more sense of how you measure your variables and how you actually implemented the survey question. And then that also brings me to the issue of how you interpreted the double hurdle and especially the second hurdle results. I thought this would have been interpreted as demand for water, where you would be interpreting the coefficients in terms of units of water demanded. But then I realized that you were interpreting them as probabilities. I mean, this may be my personal challenge with that model, so you could probably explain it maybe later to me, but I will give you a more detailed comment in terms of what I see in the paper. Finally, my last comment is on the fact that you mentioned that demand for bottled water is going up in Algeria, while supply for tap water probably is increasing. So my question is it a matter of lack of capacity from the national water provider, or it's just because the water is not available, the raw water is not available to them? So over to you, Slim and GB, and thank you very much.
Thank you. Slim, would you like to react to some of the points raised by Raymond?
Well, thank you for the comments. I mean, the paper is more extensive than what I have presented, and we are talking about probability of participation in the market, etc. So I'll take some of your comments into consideration when to improve the quality for the readers. But the issue here is not about limitation of the water utility. I mean, the city of Tunis, have talked about the city of Tunis capital here, and the water utility is providing services for 95% of the population in Tunisia. So we don't have an issue of water availability, but fundamentally it's an issue of water quality, which goes down drastically during the drought periods, and because of the drought conditions and climate change, this water utility has not invested in improving the water treatment infrastructure. So we're just assuming that we are going to get high quality from the reservoirs, and we are putting some sand purification and sand filtration and some chlorination. But with the climate change, we need to invest in more sophisticated technology to treat the water before delivering to the citizens. And that would not be able unless huge investments are taken into consideration.
Thank you. Let's open up for questions, but perhaps before I have one or two questions from my side. I think I read the paper, it's definitely a nice paper, perhaps some questions about the specification. Usually when we estimate demand, first of all, if I put things in a context, we're talking about estimating water demand function. Usually in developing countries, you have different sources of water demand, water coming from the pipe, municipal water, water that is bought from the market. And there, from an empirical strategy, one has different options, whether one goes for estimating directly the demand that is isolated, then either it's a pipe demand or bottle demand.
No, sorry. In Tunisia, we don't have market for water. We just have one water utility, which is serving all the population. So we don't have this classical problem, which we find in other cities in Africa. So it's a very well developed water utility serving all the population. So far, the quality has been good, but the quality is getting deteriorated due to climate change and to a lack of maintenance. So we don't have this question of markets and vendors and all this stuff. So no.
Right. No, that's fine. The point that I wanted to make, perhaps the terminology was not appropriate. What I mean by water market was not a structure where you have traders selling and buying water rights. But usually in many developing countries, you have water that comes from the municipality. But for drinking purposes, because the quality is not good, as you say, they buy bottled water. But the point that I want to make here is in terms of the certification, the methodology. And there is enough empirical evidence that actually shows how water demand can be modeled. As a result of that, I think variables like prices would have been good to be included here in order to reflect the incentive mechanisms that
it is included there. Sorry for interrupting you. It's included because it's included. So we are asking we included how much expenditure the household has been spending on the water bill and how much he's spending on the bottled water. So it is included.
Perfect. Wonderful.
Yeah.
Also, because of the richness of your data set, you have 880 on 43 districts. There is a lot more, control you can actually run. Because the point that I'm trying to make is, I think the paper is really rich in terms of what it can achieve versus its current status. But definitely, I can also send you an email to explain some more details. Let's open up to further questions. Okay. 1, 2, 3. Oh, sorry.
Thank you, Slim, for another interesting work. I just wanted to follow on the control. Are you sure that what you measure is the response of the customers to water quality, or also to interruption or to service level? Because the literature on bottled water pays more attention, at least so far, to problems related to quantity issues, droughts and services.
Thank you, Riyad. Yeah, I should have put you, the audience, in what is really the problem. In Tunisia, there is no problem of water disruption. We have water 24/7, no interruptions of water. Wherever you go, it's not only in the capital city, it's very high quality in terms of, it used to be much better than what we are having nowadays. But the quality is going down, unfortunately. And this quality is going down, as I mentioned, part of it is climate related, and part of it is lack of investments and lack of upgrading of the facilities and treatment facilities.
Yeah, a comment and then a question. Research done a long time ago in another part of the world suggested that the priorities for water utilities are dependability, quality, and then cost. The cost variable for them seems less important than the other. Now, what you told us is the quality and the dependability is there, but the quality is variable. And there are times of drought, or it may be events that convince people that the water quality is uncertain, so they don't like to take risks with it. Would it be possible to convince people that just as the weather varies, quality may vary, and do a public education campaign that would do notices, as you did during the drought here, about what the situation really is, and advisory, so that people change their behavior pattern according to their perceptions of quality. Then just one more comment. Price increases public acceptability. There are a lot of variations, and my feeling is that if they had more confidence in the question of quality and acceptance of the variability, they might be willing to both pay more for water services and use those water services.
Thank you for your question. Again, I mean, I haven't got time to explain the problem perfectly. So when the drought hit in, the CEO of the water utility decided to have a campaign, a big campaign, and among the decisions he has taken is to cut down the water from 9 p.m. to 5 a.m. to reduce the consumption and to reduce the leakages. As I mentioned, the leakages are 24%. So the point was to close down the system at night, so leakages would go down and save water. All right? And they started doing that. 2 weeks later, he was ousted from his office. I have a crazy president who said, no, you are creating social problems. I don't want a water interruption. I have to have water 24/7. And he was ousted from his office, literally. And they brought a CEO who was really much lower level and much lower skills in office. All right, so yeah, I mean, the issue is fundamentally related to the raw water quality that is taken from the reservoir. And again, my point is that we have to upgrade our system for treatment. It's not perception. When you open the tap and you get a glass of water, it's it's even smelly, you know. So it's not a perception that the quality is going down. It's a fact. It's a fact. All right. But the water utility keeps denying. They're saying it's safe to drink. Yeah, it's safe, but it's smelly, man. How can I drink it if it is smelly? All right. It's safe, biologically safe, but it's not water that I would like to drink.
Yeah.
Sorry.
I have been asked to stop. But
No, but let's get one more question
I
there.
see four
GB.
hands up. Therefore, there is a trade-off here. Let's get some additional questions. Oh, sorry, no.
I'll try to be very, very quick. So thank you for this nice presentation. I've just two small questions. The first one is there any correlation between education and income? Because in the specification of the model, you have both education and income, and we know that there is a risk.
There is a correlation.
There is a correlation. And you, as an explanation, you say that there is not much investment in treatment infrastructure. And what I see, for example, in our case in Morocco, is that even if there is appropriate investment in infrastructure, there is operational costs that are very high when the quality lowers down. And this, especially in this case, because we have exactly the same problem during drought periods, and they leave the quality, like you said, the quality seem or perceived low, while normally biologically it is not, but it's only for the operational costs reasons, not for the lack of investment in infrastructure.
Oh, well, indeed, in Tunisia, it's a problem of infrastructure. As I told, I mean, the only treatment is being done there is sand filtration and chlorination. And this is really an awkward technology compared to what we see in the developed world in terms of treatment of drinking water. I mean, I don't want to talk about new contamination, micro contaminants. It's another big issue, but at least, I mean, to provide the quality of water that has no smell and no taste at least. Yeah.
Thanks for that answer. I've been to Tunis myself for some project work, and based on the results of an ongoing project that we have in the region, 2 publications a couple of years ago, one thing that we found is that when you give decision makers in these political appointed offices a drought plan, a drought contingency plan that has steps in it that would state clearly what happens when reservoir levels reach a certain percentage, then perhaps prices increase, then it reduces the pressure on these decision makers. And they can say, this is in the contingency plan that we agreed upon in whatever year, and it was done in advance. And this has nothing to do with me deciding to increase your price, but we've all agreed to this. So it can lower those political costs. And I was wondering if you've seen evidence of that. You don't have to answer it, because I know that there are other comments and questions. And one other thing I wanted to add, from a social science perspective, it's incredible that you had a 95% response rate on the surveys. And I'd love to hear how you did that.
It's a door-to-door survey. And we sent ladies for the interviews in a door-to-door, so to have more confidence with the people living at home rather than sending a man. So we solved that issue by sending young ladies to go give more confidence that when you open the door, you have no threat. In Tunisia, we don't have this safety problem that you have. Still, people, I mean, trust. There is a trust, a social trust. So that was one thing. But again, I mean, when it comes to quantity, what the water utility is getting the water at the expense of farmers. That's another issue I don't want to talk about. Now, in case of a drought, the absolute priority goes for drinking purposes, for urban use, and then we cut down the water for farmers. And that's another big issue, how we should be doing it in a different way to create a market. Whenever there is a drought, farmers have to be compensated for the lack of water. They are not getting water at all. So, yeah, it's a complicated and complex problem.
Oh, all right. No, I'm sure there are a lot of things to be said, but I'm being asked to move forward. Let's get Maria and proceed.
Right, so good morning, everybody. Well, I'm María García from the University of Oviedo, and I'm going to present part of research project because it's much broader than this that I'm going to present. And I'm going to talk about a very controversial issue, which is efficiency. We talked about it before. But we adopted a different approach because we are talking about the efficiency of water at the demand side or consumption side, not at the production side, right? So we are analyzing or assessing the efficiency of residential water demand. And actually we are focused on the role of information. When people have more information about water issues, this can have some kind of impact in the potential savings that they could have in terms of water use. So it's a paper jointly with a couple of colleagues from the University of. So this is basically the outline. First of all, motivate the paper by means of an introduction. Second, just briefly mention the literature review, the previous literature review, in order to understand the contribution, our contribution. Briefly, the method that we have used is quite a standard. And also, I think I'm going to spend more time on the data set and how we build the data set. We merge different sources of information. Finally, some results and main conclusions and policy implications. So basically, from international institutions, maybe we have the message about the necessity of improving the efficiency on water use, especially in some areas which are really under pressure. And well, me as an economist, I've been focused on the demand side approach, the demand side policy. So in that case, yes, both pricing and non-pricing policies have been proposed to manage water demand at the residential level. That is basically where I focus. So if we focus on prices, for instance, which is quite a discussed tool in the literature, we observe that different kind of firms are aimed when designing water prices at the residential level. And this has increased the complexity of tariffs in several parts of the world, including Spain, that has a very interesting map of water tariffs in different cities. So as a consequence, there's a lot of misinformation in the sector. So that means that residential users don't have a lot of information on financial issues and also consumption issues, right? So this is basically something that we have observed. So the idea with this research is to assess the efficiency of water consumption, of household water consumption, and we contribute in different dimensions. First of all, we model a demand function, but this is a special demand function because it's a frontier. As in production analysis or efficiency analysis, we have like a function where we can identify the best performers, the households that are using less water to do the same, right? To do the daily activities, both indoor or outdoor, right? We are considering both dimensions. We use a novel and exclusive database for a representative sample of households in the city of Gijón for a long period of time. And we also assess the role of information that they have on prices, bill, and consumption on that levels of water wastage, because we are interested in finding out the role of that information. So regarding literature, previous literature, we found really a lot of papers that have analyzed water demand at the residential level. There are plenty of them. You can see them, some references that are surveys that you can take. And majority of most of them just conclude that, water demand at the residential level is price inelastic. So they just estimate values lower than one. So if we look at the papers that have analyzed efficiency of these residential water consumption, there are not a lot. We can find a lot of very important line of literature in the case of energy water demand at the residential level. So there are some papers of, for instance, Massimo Filippini, an Italian colleague, that have developed this. In terms of water, I only know a couple of them, and they are not really very frequent in the literature. So the idea is just to contribute to increase this literature, right? So I just mentioned these two. And in both of them, the role of information is not analyzed. It's analyzed the role of technology, which is quite important, but not the role of information. And there are some papers also that have assessed impacts on misinformation, but on residential water demand or consumption, right? For instance, the paper of Binet that said that people that underperceive water prices tend to consume more water, right? Also, Brent and Ward that found a different or opposite conclusion, different results, because in some cases, informing people about prices could even lead to increased consumption in some situations. So it's not clear which is the role of information. Sometimes having more information led to higher consumption, having less information led to lower consumption. So what about the method that we have used? Is very standard. We used a frontier analysis. So we estimate a frontier demand function for households, and we assume a demand function based on a Stone-Gear utility function, which means that this here, this term, which is the income divided by price, which is characteristics of this functional form, and then we have like the covariates, typical covariates in the case of a demand function, right? And the difference with the normal demand function is that we have an error term which is divided and split in twice, right? So the usual error term, but also the inefficiency error term. So that's what we are interested in analyze. And also after estimated the water demand, the frontier demand function, we are calculating the inefficiency and trying to capture the impact on different factors on that water waste, right? So among those factors, we consider some technological factors, but also information, the quality of information that households have on different, let's say, water dimensions. So relating the database, we just built a database merging two different kind of sources of information. First of all, we get some actual consumption and pricing bill and data from the water company in Rincon, because Playa analysis is located in a medium-sized city at in the north of Spain, very close to the sea. So it's a green area. People don't perceive that there are scarcity problems, but sometimes we have. And actually, there's like a regulation which is being designed now and decided and discussed to be prepared in the case of a drought. So in that case, politicians are thinking about designing a different water types in order to deal with the drought period. So this is on the table now. So we just merged that information with information from a survey that we conducted. Actually, we conducted the survey during the COVID crisis. So it was a bit stressful, but finally we could do it. So for instance, we could not do it face to face because it was forbidden at the time. So we need to mix different ways. And actually, Gijón is one of the most or the more aged populations in Spain. So I think that more than 25% of people are older than 65. So for instance, you cannot think about some technological ways to send information to them because they are not too familiar with smart telephones and this kind of stuff. So this is basically our database. And also it's very important that you can see a picture of Gijón, and the range, the mountain range is far away, but it's called Picos de Europa. And it's a relatively famous mountain range in Spain. And you can see that it's in front of the sea. And it's a municipality with some urban areas, but also rural areas. You can see here some hills. And then there are some households living there in detached houses. And the way they live is a bit different, and also in terms of water use. Because in the rural areas, there's a higher probability to find houses with gardens and swimming pools are there, not in the city. In the city, people don't have any swimming pool, right? So we decided to consider two different kinds of subsamples. So people living in apartments in the urban areas, and then people living in detached houses in rural areas. So that was the idea. So we estimate a frontier demand function for each kind of household. Regarding prices, why people, because we will see later that people don't know a lot about water prices. But basically it's because they are a bit complex. The tariffs are a bit complex, and also because the amount of money that they're paying is not so high, right? So for instance, a very interesting characteristic of water pricing or water prices in Gijón is that, of course, we have like two-part tariff with a fixed charge, but also a variable charge depending on the consumption, increasing block variable charge. But at the same time, we have a regional sanitation tax, which is also based on blocks, but is a super progressive structure. That means that you apply only one price to the whole amount of consumption. However, the water tariff at the city level, it applies different prices depending on the consumption. So it's quite difficult to understand. Even some people, some of my colleagues at the beginning, they didn't understand how the tariff works, right? And you see that the average marginal price is not so high. And most people are in the first block of consumption, which is 30 cubic meters for 2 months, because bill is sent with a frequency of 2 months, every 2 months. So there's a high share of households with showing some misperception problems. And actually, well, I will show it a bit later, this percentage. So first of all, I'm going to show you the kind of variables that we include in the demand function, which is a frontier demand function, but in the end, it's a demand function. So we just look at the previous literature and we include these kind of things. So we include this ratio, income divided by price, because of the specific functional form that I mentioned before. And we, since there's endogeneity of water prices, we correct it with control function approach. So that's why it's in yellow, because it needs a special treatment in terms of econometry. Then household size, the percentage of women in the household, and the percentage of employed and self-employed people in the household. Right? And also some housing features, like if the house has more than 40 years old, that's variable. And in the case of frontier for detached houses, if it has pool or has a swimming pool, and if it has a garden, right? Some climatic variables, temperature, humidity, and rainfall, and then some temporal damage in order to capture some seasonal issues, but also some shocks. So for instance, we can think on the yearly damage and think on COVID issues. So those are the variables included in the second part, but we regress the inefficiency against some factors. So we include these technological variables, so we capture with them the quality of appliances and devices that use water in the house, right? So basically, if we have like this efficiency taps, shower heads, or the dual flush toilet, and also if we have like this washing machine and dishwasher efficient appliances. And those are the variables related to misinformation. So basically, we consider misinformation of 3 dimensions, which are prices, consumption, and bill, right? These 3 dimensions. And we consider, first of all, if households are under-perceiving these variables, but also a lot of them answer, I don't know, have no idea about what I'm paying, what I'm consuming, have no idea. Absolutely. You will see the percentages now, the shares. So you can see here differences in terms of where the households are living in rural or urban areas. So you can see that the consumption at urban areas is much lower than at rural areas. You can also have some slight differences in terms of family size, but not a lot. And also some differences in terms of the percentage of people, employed people or self-employed people. And usually we have newest houses in the rural areas and in urban areas. Actually, there are a lot of old buildings in the city center. That's quite characteristic. You can also see the percentage of people that have a swimming pool. It is not so huge because in the north of Spain, sometimes the weather is not nice to have a swim, even in the summer. And then there's plenty of households have a garden. Look at then to this misperception index. This is a dummy, so it's yes or not, right? So look at, for instance, that almost 70% of people don't know how much water they are consuming. They say, no, I don't know, have no idea. Also with prices, but however, in the case of price, you see that apparently people living in rural areas, they are aware, or not aware, but at least they give you an answer to the survey. They say, no, it's this or it's that. But in terms of consumption, we can also see a very high percentage of people that, don't know anything about this. And also the people that are under perceiving prices, consumption and bill, the percentages are a bit lower. So just moving into the results because I have not a lot of time. Just very quick. This is the demand function, the frontier demand function. So we observed that we found like the typical results in previous literature, right? So we don't have anything that can be mentioned. For instance, well, the typical coefficient in the case of income, family size, of course, increased there because the dependent variable is the daily water consumption of the household. Also, we observed that the percentage of female in the household reduces the daily water consumption. And also, if there are more employed people or self-employed people in the household, because probably they spend more time out of the house. And then we observe here that in case of old houses that have some problems with pipes and so on, the consumption is a bit higher, right? And then here you can see, for instance, the effect of COVID crisis, clearly here, with the 2 coefficients in 2020 and 2021. And I don't know exactly, well, I know it, why the consumption is higher in the first semester, each month, 2 months of the year. Actually, in the summer, there are some people leaving the city, so maybe that's one of the reasons. Just looking for hotter weather. And so, regarding the key drivers of water wastage, we observe here, like all information variables have a positive impact on the inefficiency. And we just calculate the inefficiency indices a bit later, but here we raise the variance of the inefficiency against these factors. So we observe that the positive impact of having less information on the levels of efficiency. of inefficiency in this case. And also the negative impact of technological efficient technologies on water. This is not clear because sometimes people have very nice technologies, very green technologies, and then they use them not very nicely, and then consumption is high, right? So if I have, for instance, to have a shower or wash my hair, I probably will need a bit of time just to remove the soap from my hair. So maybe it doesn't matter that I have my efficient shower hair, sometimes. So here we calculate efficiency scores, and we kind of said that we have like what we expected, that people, uninformed people are much less efficient than informed people, or misinformed when you under-perceive water prices and so on. So very quick, just to conclude, because I have no time, and Christina is just telling me that I should stop. But we provide some evidence. We saw that real information matters, that households don't have a lot of information on water issues. We should improve that information because that could generate efficiency gains in terms of water use. I'm not talking about quality. Actually, I'm assuming that the pollution is similar in all the cases. I don't have information about that. So as a policy conclusion, I would say that we should promote information in this field. Sometimes it's not clear that public authorities want to promote the information in this field. And actually, it's good to conduct informational campaigns, nudges, and so on. And actually, part of these households in the sample were nudged a bit later. So this is an example of one of the informations that we sent. So here you can see how we explain, it's in Spanish, but anyway, you can see how we explain the blocks and the regional tax, which is a bit complicated, and how they can save money if they save water, and then can pay more if we increase, like a marginal increase of water also. So thank you very much for your attention, and I hope for your comments.
Thank you very much, Maria.
Thank you very much. Thank you, Marianne, for this wonderful presentation and this innovation in the way you consider the frontiers, efficiency frontiers. So fundamentally, your paper brings in an innovation in terms of efficiency frontiers when it comes to information. So your assumption is fundamentally based on the following. You say people who are well informed are more efficient. That's your assumption. The assumption you depart from. Okay. So and when you say information, the three variables you have been considering are the price of water, the water bill, and the volume of water. All right. So this is the core of your paper, as I understand, because the other part is classical part in terms of efficiency frontier. So I just want to discuss this assumption from a theoretical point of view. The first comment is that in reality, if it comes to water, the only person who might be knowing the price of water is the head of the family, so the one who is paying the bill. Usually, I mean, I'm just trying to raise some questions for discussion. I'm not okay. So fundamentally, I give you the example. I'm living in a house with my wife and daughter. My wife and daughter has never come to know what the water bill is and how many cubic meters of water we are using on a monthly basis. So can you please justify in terms of your theoretical approach and assumption when it comes to this issue? The second issue, there is a number of papers that have been addressing this information in a different way. So around the world, many water utilities have been moving to smart water metering. And among the advantages of smart water metering, users are getting information sometimes on a daily basis, and benchmarking, comparing the user with his neighbors, how many liters per capita per day, and how much water is being used and how much it is costing him. So smart technology is in some sort addressing that question of information, but yet I haven't seen papers using this bunch of information to work on efficiency in the demand side. So this is fundamentally my major concern with. It's not a concern; it's just a comment about your paper. And then I'm going to open the floor for questions. Okay, so you wanna respond to this?
Yeah, so
go ahead.
I think I can answer. Yeah. Yeah, probably in the house we have different people with different roles, but I don't know exactly what's the meaning of head of the house, because sometimes different aspects of the house are controlled by different people in the house. It's true that, for instance, if the respondent is one of your kids or your children, maybe, or children, adults, because all the respondents are adults, but yeah, maybe he has no idea about that. But let me tell you another thing also, which is that me, for instance, I don't receive my water bill at home. So unless I check the meter, I have no idea, because there's like it's a minimum amount of water which is charged for everybody. It's 10 cubic meters or something like that. So yeah, so I have no idea about my water consumption. That's because the way in which is charged to me. So there are a lot of other problems that can have impact on this misinformation. And regarding smart technology, well, I know some papers that have analyzed the impact of smart technology and having like daily information and very nice rows and graphs on your mobile phone, but on water demand. But for instance, you saw the notch that I showed in the last screen. So we could not send that nut using a smart technology, because sometimes, as I mentioned in one of my interventions, the acceptability is not clear from different points of view, not only the clients, but also the company. And yeah.
Yes,
thank you.
May I have a small question on the concept, Maria? I think very good presentation, very innovative. But I'm trying to get my head around what you're measuring. Demand function, right? So what's the dependent is total demand. And what's on the right side, prices and budget, right?
Yeah.
So first question is, do you have budget, do you have other prices? Or you estimate a reduced demand function, then you have to take the derivative of the demand with respect to the water price, and then all the rest has to be related to the water price. That's my first thing, because I'm struggling with the link to the frontier. So what are you optimizing? What's your fundamental assumption to apply a frontier concept here?
Yeah, so you do it in the same way you use a production approach.
Yes, but there you optimize production, profit, or revenue, or costs.
Yeah.
But what are you estimating, optimizing here?
Yeah, the idea is to reduce the consumption. I mean, the best performance are the households that are consuming less.
But then you would need prices for other goods, and you would need a budget somewhere.
Yeah, you will need a lot of things, but sometimes in literature on water demand, in general, not frontiers, in literature of water demand, we used to consider only the price for water demand. If you look at
but how can I don't
it's not
extend this, but how can you talk about optimization if you don't consider the other variables that are relevant for the individual decision to optimize the utility out of your budget given prices?
Yeah, because I don't have that information, and usually most of the papers that work with that don't have that information, don't have a complete information on the expenditure bundle of households. That's the reason. Yeah, and so most of the papers estimating water demand function, just demand function, only consider price. And here we didn't have any other price in this or expenditure in this. Yeah.
All right. No,
One more question.
no, that's okay. No, that's fine. We can have, perhaps if I can just react to that, Johannes, I think the same way people, they run DA, data envelopment analysis, in the supply side, that's what you're trying to do here. But from the demand side, that's how.
Yeah, but it's not. It's parametric approach.
The stochastic side.
Exactly.
That's fine.
Exactly.
Perhaps what makes it a bit difficult, in my understanding,
yeah,
is the way the water that is wasted was introduced to establish a stronger connection between the efficiency you highlighted and the water that is wasted. It's perhaps a way for you to cater for the demand approach and not the supply approach. I don't know. That's just my reading from what you presented, but that reading might also be wrong.
Yeah, we basically based on the electricity or energy literature that they apply it a lot, and they consider only sometimes the price of energy. And yeah, the question is that you consider a frontier, but it's a demand function instead of that. Okay.
I'm told that we need to stop.
Okay, thank you very much, Maria, for the paper and for the presentation. Thank you.
Thank you very much.
All right. The next presentation is given by Raymond. Raymond, are you online?
Yes, I am.
All right. It's over to you.
Thank you very much, GB. Okay. 1 minute, I'm trying to share my screen. Okay. So thank you very much once again, GB and everyone, and I must apologize for my inability to be there in person. So this is a project I've been doing with GB and Professor David Stadelman. Of course, GB is a professor in Cape Town, and I'm currently working with the European School of Political Sciences, Political and Social Sciences. So our concern is to analyze resource extraction and water security in Africa. Of course, this looks a bit research, but what we do here is to look at the role of local government in the mining or resource extraction and water security nexus. So to the extent that most African countries depend on the primary sector, then you also realize that the mineral resource sector constitutes an important aspect of most economies on the continent. And this comes in the form of employment provision and also direct and indirect livelihoods. Then, of course, at the macro level, you would have countries earning significant amounts of their foreign exchange, raising taxes, and also getting infrastructure from the mining sector. But one thing that is very clear to observers in the sector is the kind of intricate relationship between mining operations and water, that water is really an important resource for the mining sector in various aspects of the mineral resource processing. So industry, mining companies need water, for example, cleaning and also washing minerals. And sometimes the mining itself is done in waterbeds or very close to river bodies, and this present the challenge of water pollution and other chemical pollutions that could affect the quality and also the quantity of water resources. And we highlight this point in the fact that most African countries or most people in Africa face some form of water insecurity. But if we look at the current statistics, then we have about 1 in 3 Africans facing water scarcity. And if care is not taken, this situation could even be worse. So it is in the light of those concerns that we actually try to observe the relationship between mineral resource extraction and water security. Of course, all is not very gloomy when it comes to the effect of mineral extraction and its effect on livelihood and water. So we have situations where mining corporations provide social projects like water provision or water infrastructure, directly providing education or school buildings and health infrastructure. So these are areas through which mining operations try to ameliorate or reduce their negative impact on communities. And of course, in doing this paper, we observe from the literature that have really analyzed the relationship between mineral resource extraction and water at the micro level, that basically most of the papers so far are finding a positive relationship between mining and livelihood improvement. So in that regard, we would say mining tends to improve livelihood, including water access. However, emerging concern in the literature, and here Diallo has done a bit of work showing that some of these social interventions are not really sustainable, such that when the mining corporations or operations cease, then you have communities becoming poorer and poorer. So in that aspect, one would want to look at the sustainability of this project, one, and also the sustainability of the mining process itself on the environment and also livelihoods. And here we think that local governance quality might have a role to play, and this is our concern for this paper, or our objective for the paper. So here we look at the local institutions in terms of their ability to supervise and monitor mining operations so that they conform to environmental standards in a way that they might not have so much negative effects on the environment, including water resources and water bodies. And of course, we've already mentioned project management and provision of projects. So how do local institutions take over projects that were initiated by mining corporations in order to make them sustainable in future? So basically, we examined two questions in this paper. The first one is the effects of mining on water security, and then the role of local government in the mining water nexus. So how do we set out to achieve those research questions or those research objectives? So one, we rely on micro level study. So we do a micro level study that uses the Afrobarometer data set. So we use rounds 2 to 6. This provides us with individual level data set that helps us to measure whether the household has been water secured or not in the past 12 months. And in addition, also, it has several control variables that will help us in our regression. Then regarding mining, we get our mining information from the Africa Power Mine. This is data set provided by the World Bank, and this gives us a mine level information, including the geocoordinates. By the way, the Afrobarometer data set also gives us the geocoordinate regarding the primary sampling area of the respondents. So our main variables that we are interested in this paper, of course, is water security. That is whether the household has gone without water or clean water at least once in the past year. This is from the Afrobarometer. In the main paper, which the results I don't present here, but we also examine auxiliary variables like food security, fuel security, medicine, and income. But these are mainly used as robustness checks to see whether we find consistent results across different livelihood indicators. So the right-hand side variable, which as our independent variable, is the household's exposure to mining operations. And here we construct two different variables. That is the number of mining operations or mining companies within 0 to 50 kilometers of the household, and then again the number of mining operations of mining activities within 50 to 100 kilometers. So these are constructed so that they are mutually exclusive. And then regarding institutional quality, we measure this at the administrative level. So in the Afrobarometer, there are several questions that would help one to construct institutional quality at that level. So the first is whether the individual trusts local councillors and whether they think local councillors or local tax collectors are corrupt, and how they approve of local government and accountability. So here we look at whether they have access to the local administration in terms of their local administration being ready to listen to them, or whether they've made contact to the local administration in the past 12 months. And then on service delivery, the question is whether the local administration, how the household assess local administration's maintenance of roads and markets in their locality. So basically, we employ a regression framework to analyze the data and also to answer our research questions. So the baseline would be to examine the impact of mining on water security. So water security is measured 0-1, where 1 is when the household has been without water or clean water in the past 12 months, and 0 otherwise. And mine there represents the number of mining activities within the various radios that we have identified earlier. Then the second objective is done through, again, a regression framework where we interact the mining activities with the institutional variables and see how the household is affected by those variables. So this is the result from the first equation, where we try to examine the effect of mining activities on the probability of household water insecurity. So basically what I said was that we have 0 to 5 kilometers radius and then 50 to 100 kilometer radius. But apart from that, we also measure or construct another variable that tells us whether the mining activity or the mine operation is active or inactive. So in effect, we have 4 right-hand side variables that measure exposure to mining. So the first is the number of active mines within 0 to 50 kilometers, number of inactive mines within that radius, and then number of active mines within 50 to 100 kilometers. And again, the number of inactive mines. So here I extract the coefficient from our regression model and try to present it in a graphical form. So basically what we see that, of course, there's some level of significance or some level of effect of mining activities on water insecurity in Africa, but the coefficient, as you would observe, are quite small. But beyond that, we also see 2 different outcomes. The first is what is observed, as I mentioned earlier on in the literature, that mining, when it's active, tends to have some positive effect on household water security. So you see that the number of active mines within 0 to 50 kilometers tend to reduce household water insecurity. We do not find any significant effect with the number of inactive mines. But beyond that, then you also realize that households that live quite far away from active mines tend to suffer water insecurity. Again, also the effect is also significant when the mining activities go inactive. So here we interpret the results in 2 ways. What we say is that, of course, what we observe with the active mines within the 0 to 50 kilometer could be the fact that the mining activities or the mining companies are able to provide adequate compensation regarding the provision of clean water to actually take away the negative effect. The other explanation is also the fact that people earn their livelihood directly from these mining activities, and they are able to use their income to buy clean water, whilst people who are far away from these activities do not have these opportunities. Because they are a bit far away from the activities, they don't have the same opportunity of employment, and then mining activities also tend to concentrate their social responsibility within the catchment area, which may not go beyond 50 kilometers. So this could explain why we observe this effect here in this model. Now, what we are doing here is that before we even go into the interaction term, we try to observe the independent effects of institutional quality on household water insecurity. And what we basically observe here is what very consistent with what the literature would suggest. So when people, for example, have contacted their local government in the last 12 months, then we tend to have water insecurity increases. So this could be that people are contacting their local government because they have challenges with the water quality or access to water due to the mining activities or due to different reasons. Of course, when people think your local councillors or tax officials are corrupt, then you realize that water security or insecurity increases, meaning that corruption is bad for water security at the subnational level. And then on the right-hand side, you also realize that variables like people's approval of their local government, and when the local government tend to listen to them, or when they tend to maintain roads or provide services, then you realize also that these are reduces water insecurity. So basically, quality local government or good institutions at the subnational level is good for water security. And once the institutions tend to worsen, then we tend to have water insecurity. JB, I'm not sure if you can see the coefficient well, but what we are doing here is to present the interaction terms of the institutional variables with the mining variables. So here we only present the results for 0 to 50 kilometer variable, the number of mines within that radius. And the way we present here is a bit confusing. So let me try to explain what we do with the columns here so that we are able to follow what you are doing. So these, of course, in all these models, the left-hand side variable or the dependent variable is water insecurity, which is again measured 0 to 1, 1 for water insecurity and 0 for other ones. So when you see trust here, then what it means is that the institutional variable that we are dealing here in column 1 is the trust variable that is interacted. And here we just use a shorthand to represent that. That is the quality of local government. So it varies depending on the model that we are running. So what we observe in this table, again, is the fact that active mines tend to improve water security. And then quality of local government also consistently improves water security, such that when institutions are good, water security is also better. And active mines also tend to have the same effect as we observed earlier on in the first figure. The first interaction here, we are a bit skeptical in interpreting it because of the well-researched literature on the effect of mining on institutions. So we think that this could go either way, whether mining influencing quality of local institutions or local institutions influencing mining activity or the effect on water security. However, in the inactive mines, we think this provides us with a bit cleaner identification because once the mines are inactive, then we think their effects on the local institutions are quite reduced. And so we may be able to examine what exactly happens to the effect of these activities when institutions are good. So when people trust their local institutions, as we see here with this interaction in the first column, then we realize that the effect of inactive mines tend to reduce. So even though inactive mines tend to worsen water security, the effect is lower when institutions are trusted or when the institutions are good. Then when people make complaints and local government listens, then you also realize that in columns 2 and 7, the effect is lower. Of course, corruption tends to worsen the plight of people who are quite far away from inactive mines. So in conclusion, we observed that nearby mining activity and its effect on water security is non-linear. It depends on how far you are to the mining activity. So those who are very close to the mines tend to benefit, and those who are far from the mines also are worse off. However, distance in terms of distance in terms of space and time also matters, so that when the mines go inactive, then you also realize that people are worse off. Again, from our local government regulations, good institutions improve water security. This is no surprise, but poor institutions are also associated with water insecurity. What it simply means is that effective local government would minimize the downsides of mineral and water extraction. So this would be our results so far. I thank you very much for your attention and hope to hear your comments and questions and suggestions. Thank you.
Thank you. Thank you, Raymond. Now I invite Maria.
So thank you, Raymond, for your nice presentation. And I just have some comments, basically, or suggestions related to the how you deal with analysis, and maybe to put out some extra information on extra variables. So what I understood is that your dependent variable is based on a survey, so it's a self-reported water security, right?
Yes.
You ask for if you get clean water, or how is exactly the question is, did you get adequate clean water?
So yes, the question is whether the house would have gone without clean water at least once in the past 12 months.
Okay, so yeah, the question is mixed in like quantity and quality issues. And yes, sometimes the questions are like very broad, and yeah, but this clean water for me maybe is not clean water for you. Slim just mentioned that if this is smelly and is brown, so it's dirty, it's not clean, but sometimes it's not so clear. But anyway, I wonder if you have any objective indicator for water quality and the continuity of water service in some cases, not because you consider plenty of households in different countries, in different regions, then maybe you could focus the analysis in one specific area and try to get some indices, objective indices of these things. I also wonder about the because you consider the number of mining activities.
Yeah.
But I also guess that there's not the same. There are differences depending on the mining type, so pollution could be quite different. So I wonder if you considered at some point the kind of mining activities that were developed. And also, I was thinking that you talk a lot about local governments. So I was wondering about water governance and, for instance, decentralization in terms of policy. So I was wondering if local governments are always the responsible for water, health, and all services, or maybe there are differences since you consider different countries and different fiscal federalism frameworks. And the final point is related to the methods. So what I understood is they use the oilless technique. So I was wondering if you try with some limited dependent variable approach. And yeah, that's it. So thank you very much.
All right. Thank you very much, Maria. Yes, it's self-reported, the water variable, but unfortunately at this point, we do not have an objective measure of water security. Of course, this will also require that we do a primary study, for instance, and also try to collect these variables on our own. This is something that we can take up in probably future projects or future studies. So this is well noted. And of course, objective measure of water, of course, then we can clearly do that once we are doing the primary study. So the number of mining activities, this really is a good question and an interesting one which we tend to explore later. So we try to see, for example, the differences in the type of mining operation that is done, whether it is underground or surface mining, gold mining, diamond mining, are different activities that will have different impacts. So this is one thing that we intend to do to improve the water going forward. I mean, to improve the paper going forward in terms of maybe providing additional results. The issue of water governance at the local government level is really challenging in that regard, because we are now lumping a number of countries with different levels of decentralization together. So this is something probably that I would have to, or we would have to look at closely to see whether there's a way to really separate the issues or separate countries according to the level of decentralization and how much local government could manage local water projects on their own. Yes, so we tried with the logit model, and the results are quite consistent, but of course, the linear probability model is always easier for interpretation, and this is why we adopted it. Thank you very much, Maria.
There any other question from the audience? Not yet.
Thank you very much for your presentation. I was just wanting to add to what Maria had asked around the water quality. It would be interesting to know differences between water quality issues due to processing challenges because of poor local government ability to deliver clean water, and pollution, and to kind of separate out the two. In South Africa, we've got severe problems with acid mine drainage. So households may be receiving clean water, but their environment might be heavily polluted, and it might be impacting their ability perhaps to use that water in other forms for irrigation and so on. So that is just something that would be good to highlight, even if you can't get those figures, just to note whether or not acid main drainage is a problem, and whether the water quality issues are due to processing issues, or whether pollution is an issue in that area.
Thank you very much. I think we take your second suggestion. We will definitely highlight this in the current paper, because I think the data we have does not permit us to delve into some of these questions, but definitely we will highlight it as a limitation of the paper and see what we can do moving forward in future research.
So thank you very much, Raymond, for the very interesting presentation. I just want to add to what Maria said earlier on. If you just talk about mining as a concept, as she rightly pointed out, it appears to kind of miss the real differences underground. I mean, I don't know, your name tells me you come from Ghana, I come from Ghana, and I think you will know the difference between illegal mining and then the normal mining by Ashanti Goldfields and these established mines. It is the illegal mining that normally leads to pollution of water bodies. So if you lump everything together as mining activities, you will be missing what is actually impacting on the water insecurity or pollution and all those activities. I mean, the second point is what she also mentioned about your estimation technique. If I understand right, your dependent variable is binary. And then, if I understand her, you use ordinarily square methods or linear probability. I don't know. Any of them will be wrong, because there's definitely endogeneity between this dependent variable and water insecurity. So you need to take that very seriously into your estimation if you want to get it published somewhere. Okay, thank you.
Thank you very much, Prof, on the estimation bit. We will definitely consider that again and see what we can do with maybe the probability model or the logit model. And on the issue of illegal mining, I think you are perfectly right. Of course, it's really a big question in Ghana now in terms of its effect on water. But unfortunately, the data set we have only gives us the number of commercial, registered, or legal mining activities. So I think in the paper we highlight that even though we see some coefficients and some effects, that this could be really the minimum points of the expected effect, because once you bring in the illegal activities, then probably we might even have the situation where the positive coefficients would turn to negative, and then we'll have negative effect on water. But this really is a bit difficult to measure in our data set now, because we only have secondary data which captures registered legal mining activities.
So I have two questions. The first one is, do you control the distance to water sources? I think it is one important a factor to for access to water resources. And the another one is that I'm wondering that open mining itself affects the quality, institutional quality. So, for example, if the mining open, then increase the regional income, then maybe it includes a lobbying activity. This affects the institutional quality, I think, and if there is, it leads to empirical issues. So, yeah, thank you.
Okay, thank you very much. Yes, we agree that there's that bicausal relationship between institutional quality and mining operations. So this is why in the interaction or the last regression results, we try to maybe dwell on inactive mines and mines that are households that are a bit distant. But again, one could not really convincingly deal with that relationship. The best option would be to find an instrument for institutional quality, which we are basically working on now to find a good one. So we have taken that into consideration regarding distance. So we do not directly control for distance to water, but I think we have a variable that captures whether there's a pipe-on water in the community, which we include in the empirical model.
All right, thank you. Thanks, Raymond. We have to go for lunch. And what time are we coming back?
I needed to push everybody. We're about 30 minutes behind, so we could go till we could still go to 12:30, and then I don't know, maybe stay till 4:15. If we stay on track the second half, but
okay, then that's fine. And let's say it's almost 12. Let's say 1:30. At least 1:30 is fine. Then we have time also. It's problem. All right. 1:30. 1:30. Oh, it's too late?
no.
It's going to be quick. Okay, then that's fine. That's okay. 12:30 is okay.
Plus or minus.
Plus or minus, yes. Yeah. Yes. 12:30. 12:30. No, 12:30.
I'm curious about coupons, too. I don't know.
We are coming back at 12:30, not at 1:30. 12:30, right? Not 1:30. Okay? We have
1:30.
45 minutes.
Okay, enjoy your lunch.